Okay, we are working in section 6.5 today, and we will be doing Pythagorean triples, some notes. Pythagorean triples are any three whole numbers that fit a squared plus b squared equals c squared. By whole numbers, I'm meaning no negatives, no decimals, no square roots, and no fractions. Pythagorean triples, again, any three whole numbers that fit this. For example, 3, 4, 5 are a Pythagorean triple because 3 squared plus 4 squared equals 5 squared. And that's 9 plus 16 equals 25, and that works. What if we try 4, 5, 6? 4 squared plus 5 squared equals 6 squared. That's 16 plus 25 equals 36. No, that can't work. So 4, 5, 6 is not a triple. Some other triples. Let's see, a 5, 12, 13. That one works. I'm not going to spend some time writing it all out. 5, 12, 13. 7, 24, 25. 8, 15, 17. 9, 40, 41. 11, 60, 61, 12, 35, 37, 20, 21, 29. There are infinitely many sets of Pythagorean triples. I am asking you to memorize these 8 sets. And I also want you to notice that the largest number in each set is the hypotenuse. Okay? All right, let's just start working through some problems here. So we're going to look down here. I want you to solve for x by using Pythagorean triples, if possible, if they are triples, and the reduced triangle principle. We'll get there, and I'll explain to you what that reduced triangle principle is in a couple of minutes. First thing, we're going to look at this right triangle. We have an 8 and a 15. So look up here at this list. 8, 15, 17. This must be a 17, and you don't have to do Pythagorean theorem because we know that that's a triple. Likewise, over here, looking at this one, we have a 24 and a 25. If you look through that list above, you'll see that this is 7. That's a 724. Again, you don't have to do Pythagorean theorem because you know that that's a triple. When we look at this one, we see a 12 and a 35. Now be careful, this is not a triple because, and here it is right here, a 12, 35, 37, the 37 is supposed to be on the hypotenuse, but this has the 35 on the hypotenuse. So this is not a triple, and we're going to have to use Pythagorean theorem to solve that one. So we can do x squared plus 12 squared is 35 squared. X squared plus 12 squared is 144. 35 squared, I'm going to help you with that arithmetic. That's 1225. Subtract that 144. X squared is 1,081. Then we square root both sides. Oops. And x is just the square root of 1,081. Okay? Now, look at number 4. Number 4, we see a 6 and an 8. 6 and 8 is not listed up here in the list of the 8 I gave you. However, if you look at the 6 and the 8, you can divide both of those by 2, leaving a 3 and a 4. So this must fit a 3, 4, 5. And again, you don't have to do Pythagorean Theorem. You know it's a 3, 4, 5. We divided by 2 to get to the inside. So we're going to have to times by 2 to get from the inside back outside. And that leaves us with x is 10. On number 5, we can divide 51 and 24 both by a 3. That leaves us with an 8 here and a 17 here. Divide by 3. And we see an 8 and a 17. Well, that fits a 15 here. Then to get back outside, we'll have to multiply by 3, which gives us that x is 45. Again, no Pythagorean Theorem. You're using just the triples. On number 6, pretty straightforward here. We can divide out by 10, which gives us a 12 and a 13. We recognize that as a 5, 12, 13. Multiply back by 10, and x is 50. This concept of using the inside numbers to figure out the outside numbers is called the reduced triangle principle. It's the inside and outside numbers. If I'm writing too fast, then please pause the video to catch up. Flip over, let's look at the back side. And we're looking at this one, number 7, where we have a 20 and a 15. When we see we can divide by 5, which will give us a 3 here and a 4 there. That looks like it fits a 3, 4, 5, but the 5 would have to be on the hypotenuse. It's not, so this is not a triple. And we're going to have to use Pythagorean Theorem. I'm going to call this a dummy variable inside of there, that y. We can use either the inside numbers, or you can use the outside numbers. Inside numbers will give us 3 squared plus y squared equals 4 squared. Outside numbers, much harder to do, x squared plus 15 squared equals 20 squared. This one's easier. This one's harder. So we're going to do this one. We have 9 plus y squared is 16. Subtract off that 9. Y squared 7. Y is this plus or minus the square root of 7. Or y is square root 7. Now that's this number here. We're going to have to times by 5 to get back outside. So x is 5 square root 7. There's that one. Look at number 8. Ooh, decimals. Let's multiply by 2. which will give us a 5 here and a 12 there. Ooh, 5, 12, 13. Okay, outside to inside we multiply by 2, so inside to outside we're going to have to divide by 2, which means x is 6.5, or as a fraction, 13 over 2. Number 9, fractions, we're going to times by 3. Times by 3, which gives us 29 in here. 7 times 3 is 21. And we recognize we have a 20, 21, 29. To get back outside, we're going to have to divide by 3. So x is 20 divided by 3. Number 10, we can divide by 12, which will give us a 3 here and a 7. That is not a triple. So again, we have an option of the inside numbers or the outside. Inside numbers will give us 3 squared plus 7 squared is y squared. Outside numbers, 36 squared plus 84 squared is x squared. Yuck. That's too hard. Too big numbers. Numbers are too big. Let's look over here. We have 9 plus 49 is y squared. 58 is y squared. Y is plus or minus the square root of 58. So y is the square root of 58. And then x is 12 square root 58. Looking at this one, again, fractions, we're going to times by 5. When we multiply by 5, this gives us 8 square root 5 and a 15 square root 5. Covering up those square root 5s, we see at 8, 15, 17. And then we're going to divide back. 17 square root 5 over 5. There's x. For this one, number 12, we can actually divide out by 12, which will give us 1 here, a 2 square root 3. Ooh, that's not a triple. So we're going to use the inside numbers, which will give us y squared plus 1 squared is 2 square root 3 squared. Here's y squared plus 1. And the 2 square root 3, that's 4 times 3. Y squared plus 1 is 12. Y is the square root of 11. So x is 12 square root 11. One more. On number 13 here. Oh boy, we want to find this x all the way down here. So we're going to start up here in this triangle. Got a right triangle here. We see a 7 and a 25. Look back at the sheet. On the other side, that's a 24. Now I got to look at this kind of middle triangle right here. An 18 and a 24. I can divide out by a 6. That's going to give us a 4 here. That gives us a 3. That's got to be a 3, 4, 5. Oops. 3, 4, 5, but I wrote a 4, so let me fix this. 3, 4, 5. Multiply that by 6. So this side is 30. This side's 30. Then we could go ahead and look at this triangle right down here. 16 and a 30, we can divide out by a 2, which will give us an 8 and a 15. It's an 8, 15, 17. So finally, x is 17 times 2, or 34. Okay, your homework is a worksheet. This is, oops, that's not your homework. This is your homework. Here's your homework. And I would like you to change a number 5, this bottom number down here, to be a 20. And on the back side, on the number 7, E, the 8 and the question mark are in the wrong places. 8, question mark. All right, thank you very much. Please complete this worksheet for tomorrow. I will see you tomorrow.